So far we have seen how to implement stack effectively, isn't it? Now with the same way we can implement queue also, because queue is also dynamically growing data structure, isn't it so? Then let me show how to implement queue using linked list. What we do is, so we take two pointers front and rear. Whenever I insert an element, I update rear. Whenever I delete an element, then I update front. In that way I would like to implement queue. Okay, so at this moment, let's say don't worry about anything, blindly assume that this is a snapshot of your queue after some time. Okay, maybe after some 10 or 5 insertions. Now you see, this is the first element you inserted, second, third, fourth, in that way. That's why rear is pointing here, front is pointing here. If you have this kind of queue already, then how you add one more element to queue, you should think about that. Okay, so pictorially this is what you are going to do. So I am illustrating how to do Enque, right? Create a node, we know how to do that. After that, insert the value, let's say 5. Then make this one null because this is going to be last node. Then here to here try to establish the connection. That is very easy for us because we know rear, right? So rear cap next equal to this one. When you create this node, we'll have some temporary pointer along with it, correct? Because we write temp equal to get node, then temp will point to that one. So using this instruction rear cap next equal to temp, we can link here to here. Then is it done? No. Rear is still pointing to the old data, but current rear is what? This one, right? That's why rear has to move to this point. This is what the story about Enque. So I'm slowly getting confidence to implement this Enque. Similarly, let's think about Dequeue. So what's the idea about Dequeue? If you have already this kind of data, simple. We have to close this one. That means delete it. For that we know that we need a temporary pointer because we are going to move front. For that, keep one holder here and Mr. Front, please go forward. Yes. Then front will go like this. Then delete it. Correct? Is it not right? Yes, absolutely. Now, sir, but you are explaining us from, I mean, in between, right? It is not start. Initially, what will happen, sir? Initially, if you understand this model, then you can expect like this. Initially, I can keep two pointers front and rear to null. Sir, what are the data types of front and rear, sir? Definitely, they should be pointers to boxes. Box is struct node. Pointer to box is struct node pointer. That's why front and rear are two struct node pointers which are initialized to null and null. That is the QEempty condition. Understand? Let's implement IsQueueempty first. So IsQueueempty can be implemented like this. IsQueueempty. Someone definitely should pass front and rear. Okay. So here, let me ask one question. IsQueueempty, is it going to modify your front and rear? No sir, they are simply checking them, correct? If you simply want to check front and rear, then try to have same kind of pointers in your parameters. That's why I'll have from now onwards I don't write struct node. So for the rather than this I use shortcut directly. I don't tell the type of the variable, directly I take front. Okay, so directly I say star front star rear. You assume that front and rear, these front and rear are going to be struct node pointers. Okay, just I mention that star, that means they are pointers. Okay, single pointer means what? This kind of front and rear kind of pointers. Now whoever call this IsQueueempty method, they are going to pass this front value here, this rear value here. Such a way I am implementing. Okay, now when execution begins, front will have this front, this rear will have this rear. Then directly code is what? If front equal to rear equal to null. If this happens, then what? If front equal to rear equal to null, then initial condition Q is empty. Then simply return true, correct? So return 1. What is the return type I can take? Either boolean, otherwise integer. So anything I can take, let me take integer. So return 1. 1 means true. Otherwise what? Return false. False means 0. That's it. If this condition is true, then return 1 and close it. If this condition is false, so this line will be executed and we return 0 and we close the method, because we know that return will be the logical end of the any method, right? Now this is the story about IsQueueempty. What is the time complexity of IsQueueempty? After all, we have 2 lines, then I can say that order of 1. By this time you would have got experience for how to analyze the time complexities, right? Now, sir, how to do Enque? I will tell you. Before going to Enque code, first I would like to discuss idea behind Enque. Yeah, please look into front and rear. You will understand some of the details about front and rear. So front is always pointing to the node to be deleted. Rear here, if you see, since we kept here means it is pointing to recent element. Let me maintain the same semantics throughout the development of my program. Okay, so what is that? Front is always pointing to the node to be deleted. Rear is going to point always to the recent element. Ready? Start. So if front equal to null and rear equal to null, first time it happens, right? In that case, what are you going to do? So how you want to do Enque? Tell me pictorially. Definitely I create a box, I write the value, right? First time I am talking about when these two are null. Then after that we have to move front and rear to something else, correct? Where? Definitely, what was the semantic of front? Recall, front was pointing to the node to be deleted. Since when you get first node, then front has to come here because this is the node going to be deleted first. That's why front comes here. And what was rear semantic? Rear was always pointing to recent element. Is it not recent? That's why I keep rear here. So from now onwards, when front equal to rear equal to null, remember this case. So that means your queue was empty. When first time when you insert a node, this should happen. What's that? Front equal to rear equal to new node. That's it. We'll try to implement it. Case number 2, when you have single node. When you have already single node, then what are you going to do? You have a data like this and null. So already we know that front and rear are pointing here. Okay. So front and rear. Let's begin here. Tell me what you want to do. You want to create a node, that is compulsory, correct? After that we want to write the value, perfect. And so we have to link here to here, correct? Because this is going to be new rear. That's why rear cap next equal to the newly added node. What is next? We have to move rear to here. Okay. So if you see this thing, so this was exactly the same thing what we do in general also. Correct? Example you see. To insert a new node, how you do? Create a node, write the value, link here to here. Did you remember that? So same thing we are doing. That's why when you have one node, single node, then the logic for inserting new node is exactly same as when you have some arbitrary number of nodes like 10 or 15. Both are having same logic. That is what I realized. But the logic for, zero nodes, when you have no nodes, then the logic was different. Okay. So let me cover these two cases such a way I write the code for Enque. Before implementing Enque method, I would like to ask you one thing. Are you going to modify front? Yes, you are going to modify. You see, in case number 1, when front equal rear equal null, you are updating front and rear. That's why front has to be modified sometimes, and obviously rear has to be modified. Whenever you want to modify front and rear, then we have to pass them, especially their addresses to be passed. That's why the syntax for Enque is like this. Enque, please send address of front and please send address of rear and just value, right? So we are not sending the address of value because you are not going to modify the value. We are going to use the value. That's why just value is enough. This is a function call. So I am going to implement this Enque. And one more thing. Sir, why should I pass address of front, address of friend? Is there any other method? Yes. If you want to escape from that, then make this Enque and rear and front as global variables. That is the only thing. But if you really want to protect them, then definitely you have to pass them through parameters, right? Let's implement them. Now let's try to implement this Enque method very clearly. So Enque is not going to return anything. That's why return type is void. It is clear, right? Now why I'm using double pointers, you know the reason, because we are going to send addresses of struct node pointers. One address is front address, second one is rear address. Both are struct node pointers. That's why we need double pointers. Now what is the relationship between f comma front? F is a pointer to front, R is a pointer to rear. Okay, you tell me what's the idea, what is the idea of enqueuing. Did you remember with front and rear? Yes, right? If front equal to null and rear equal to null, that is a separate case, correct? So usually you thought of doing something for front equal to null, rear equal to null. Tell me what is that? If front equal to null and rear equal to null, what is the activity? We'll see. Before that, let me eliminate front because front is our illusion. We don't have front here. What we have? F. But you wanted to write front. Then simply write star F, correct? So star F equal to null and star rear equal to null. Then what happens? Definitely case number 1. Your queue is empty. Then get node. I do this separately. Get node. And get node returns what? One pointer. That let me take into temp. Okay, we know that temp is a struct node pointer, but if I write all these things, it takes lot of time. Sometimes I skip this part. I say simply temp, but you should understand that whenever I don't declare variable, still you should assume that it is declared. Okay, so struct node pointer temp equal to get node. After that what? So let me show pictorially. This is what happened. So one box is created and temp is going to point it. We are going to, this is since it's a first node, front and rear should be updated to this temp, right? That's why logic is front equal to temp, rear equal temp. Whenever front equal temp, what happens? Did you remember? This box address, let's say 100, content of temp is also 100. Now you have front box, rear box, capital front, capital rear. Okay. So in capital front and capital rear, if you write 100 and 100, they also points to this box. That is what your expectation. For that we have to modify these two places with 100. 100 is nothing but content of temp. That's why logic is star F. We know front is star F. Star F equal to what? 100. 100 is temp. Similarly star R equal to temp. Okay, done. So we can do this entire thing in one line also if you want. What is that? Star F equal to star R equal to temp. Close. Okay. After that, anything else? We have to fill the value. What's the value? Simply temp cap info equal to, what is the value? This one, right? Value. So temp cap info equal to value. Anything else? Close, right? So that's why whenever case number 1 happens, do all these things, these 3 things, and close the method. Before that, return. Simply write return. What happens? I will tell you if you do that. Then this line will be executed. If conditions both are true, will come here, will come here, will come here, and entire desired thing will be done, and simply return will close your method. That is what we are expecting, right? Else, don't write else, because if this condition is true, we don't come to this part. If condition is false, directly will come to this part. That's why remember, when you write return, in if condition, if you write return, then you don't require else. Okay, so directly I can say remaining thing. Otherwise you can write else also if you don't have confidence. So write else. In else part, what you have to do? Then in else part, you have to take a case where you have 1 node or 2 nodes or 3 nodes. Recall the logic for that. What was the logic for that? Did you remember? This is your rear, this is your front. Then we are not going to update front, we are going to update rear. I will tell you that. Create a box. That means getting node is compulsory. Again, let me take temp equal to get node. So here I am creating again temp. Okay, struct node pointer temp equal to get node. Okay, so box is created. We have to write the value. What's the logic for writing the value? So temp cap info equal to value, right? Yes, I have written value. Done. Example, this is 1, this is 2, this is 3, this is 4, this is 5. Now linking part. How to link with respect to rear? Rear cap next equal to this one. What is this? Temp, right? Currently this box is pointed by temp. So rear cap next equal to temp is a logic, right? Let me do that. Rear cap next equal to temp. Again same thing. Rear is our imagination, but actual thing is what? Star R, correct? That's why here we write star R. So this is a way easily we can develop the code. First you write with front and rear, after that you replace with star F star R. So star R cap next equal to temp. But still what happened is, the new node is linked, but Rear is not updated. That should be the final step. Let me update rear to temp, correct? So what is your expectation? This rear has to point to this box like temp is doing. Then simple, take the value of temp into u, then u will be pointing to same as temp. For that always logic will be, this one, rear equal to temp. Okay, but we know that rear is nothing but star r. So finally star rear equal to temp. Anything else? No, because of that automatically this rear will come here and new node is added. Close it. So this is the entire thing is code for Enque. What's the time complexity? Very easy to understand. In case number 1, after all you have 4 lines. In case number 2, after all you have 3 or 4 lines. Then I can say that constant for every case. Then I can say order of 1. So finally we have implemented Enque in order of 1 time. Now we'll see 2 more implementations. One is IsQueueempty, second one Dequeue. Let's begin with IsQueueempty. In IsQueueempty, your front and rear will become null, correct? And one more thing, are you going to modify front and rear, or are you simply checking whether front equal to rear? We are simply checking front and rear. That's why the best thing what we can do is we can send only values of front and rear to the method. So that method is going to be IsQueueempty. Okay, so IsQueueempty is going to take front value and rear value. That's why the data type should be single pointers, single pointer rear and single pointer front. Remember one thing, I did not complete the definition here. You should write struct node, you should write struct node. Okay, to save the time I am doing it, but you should write struct node, struct node. Now condition is what? If we know the logic, since r and f are pointers like f front and rear, so don't say star r, correct? So if r is pointer to front, we should say star r. Here r is nothing but value of rear and f is nothing but value of front. That's why we can simply say r, right? R refers rear, f refers directly front. If r equal to null, let's say, and f equal to null, let's say, then what does it mean? Definitely your queue is empty. Then return non-zero value, let's say 1. Otherwise what if this condition is false? If r is not null or f is not null, then definitely queue is not empty. Then I return 0. Okay, then this is IsQueueempty. So what is the return type? Int, correct? So we are going to use this method in Dequeue. What's the time complexity? Again order of 1. IsQueueempty also order of 1. Let's go back to Dequeue. So how to do Dequeue? So idea is simply take one holder, keep here and increment your front. Second step, that means front comes here. After that you free it. These are the 3 major things you are going to do, isn't it? Let me do that. So the method name is Dequeue. So Dequeue requires dash parameters. Let's say you don't know at this moment, definitely front is required. Without front we can't do. Let me take front pointer. One thing, are you going to modify front? Yes, that's why we need double pointer, right? So we know the idea now. Struct node double pointer f. And one more thing, do we require rear? Yes. Why we require rear? Because if you have single node, think about it, then front and rear comes like this, and if you delete it, then we have to update front to null and rear also to null. That's why remember rear also, address of rear also should be required, then only we can modify. That's why we also require struct node pointer double pointer rear, let's say r. Start. First thing what we do is, if queue is empty, keep quiet, right? So step is if IsQueueempty, okay, so IsQueueempty, and IsQueueempty works with what parameter? Front and rear. We have to send front and rear, but we have pointers to front and rear here. Then how to send original front and rear? We know, simply star f comma star r. Simply call like this. If you call like this, IsQueueempty star f star r, it will work, and this method is going to return true or false. If true means what? Queue is empty. If it is true, then simply exit the program because your queue is empty, but still Dequeue is called. There is a problem with your method or program. Else, if your queue is really non-empty, then we know what to do. Let me first write code for general version. That means if you have sufficient number of nodes, That means I assume that already you have 4 or 5 nodes. Then with that we try to write the logic, and after that we cover the special case where you have single node. Okay. So let me assume we have sufficient number of nodes. What should be the first step always? Holder equal to, let's say this is struct node pointer, isn't it? So struct node pointer holder equal to dash. First we have to keep it front. So this is double pointer, that's why front is for a star f. Next we have to increment what? Holder, sorry, front. What is the condition for that? Star f equal to star f cap next, isn't it? Yes. So this is front equal to front cap next. Okay. For safe side you can keep brace like this, but that is not required. Even according to precedences, automatically brace comes here. We have checked it, correct? So anything is correct. Either you write brace or not, doesn't matter. Now what we want to do after that? Front will come here after that. So I would like to remember that information which is at holder. That's why int x equal to holder cap info. So now I have value which is to be deleted. Okay, let me keep that in with myself. After that I am going to free that box. How to free the first box? Holder is a pointer for that. That's why free holder. After that what to do? Return that x. We'll see whether this code works or not. Okay. So definitely it works for 4 or 5 nodes. What about single node? Only this case we'll try to cover. What if you have only one node? Then front and rear will be here, and there will be only single value like 1. Okay. Let's blindly execute it. IsQueueempty, no. Then we'll come here. Then holder points to star f. Star f is nothing but front. That's why holder also points like front, because you assigned front to holder. Then holder also points to same box. Remember one thing from now onwards. Whenever I assign some pointer value to another pointer, they will point to same box. Since f is front is pointing to this box, then holder also point to same box. Next. So you incremented front. So this is front, right? So front equal to front cap next. Then front will reach to next point. What is that? Front equal to front cap next, but front cap next is null. Then front will become null. Okay. Perfect. That is what should happen if there is no node. I mean, if there is single node, if you delete it, front should be null. Perfect. After that, x equal to holder cap info. Yes. This is holder cap info is 1. X will be 1. After that, free holder. Perfect. We are going to delete it. After that, return x. Here one serious problem you are facing, that you have to update rear, correct? Still rear is thinking that you have deleted it, remember? Then that memory will be taken back by your compiler. Still your rear is not updated. According to C programming, when you assign something to, example, initially rear was pointing to this box. But if you don't update rear, still rear thinks that it is pointing to valid memory box, but it is not valid. Already we have seen this problem. This is called dangling pointer problem. To avoid the dangling pointer problem, after this code, what you do is write one extra line before returning. You do like this. If, what is that? Rear before that. So definitely front will reach to null at that time, correct? When there is a single node, if you delete it, front will become null. Then I can say that if star f, which is nothing but front, is it null? Yes. Why it is null? Because before that there was one node. Then we have to inform rear also. Then simply write star r equal to null. That means, my dear r, please realize that there is no node. Then if you do this extra step, then it will cover case number 1. Okay. For other cases, what happens? This star f is not null, then this rear will not be updated to null. This case only works for single node. Understand? For other cases, this code definitely works. Okay. Please add this extra line. So simple. In that way, we can cover all the cases. What's the time complexity of this model? After all, if condition is false, right, we'll come here 1 unit, 1 unit, 1 unit, 1 unit. Maybe if it is a specific case called single node, 1 more unit. I can say that in anyhow constant time, correct? So whenever a program's time complexity constant, we say what? Order of 1. That's it.